Okay, so here's our second week dealing with radicals. This week we're going to focus on operations with radicals, but we're also going to have to simplify them. There's no assessment for this week, so just make sure you're keeping up with the notes. I'm going to try to fit all of this into one video, but if you need to, pause my video halfway to complete some of the problems and then continue on another day. Remember, if you are a little stressed out, you can only focus on the odds if you'd like to do that. And then next week, there will be a cumulative Albert on all of the radicals. So we're still going to simplify radicals today, but we're also going to add and subtract radicals. So it says to identify the radicals with the same index and same radicand. So I'll show you what that means. If you had something like 2x plus 5y, those are not like terms, so you would not be able to combine them. But if you had 2x plus 5x, those are like terms, so you can simplify. It's the same thing with radicals. If you have radical 5 plus radical 7, those are not like terms, so you can't simplify that any further. However, if you have 2 radical 5s plus 3 radical 5s, that would give you 5 radical 5s. So think about whatever that radical is, think about that as your variable. If they're like radicals, then you can add or subtract them. If they're not the same, then you cannot add or subtract them. So let's do some practice problems. So on the Albert next week, you're going to see something that's super similar to this first example. Okay, so you see that the number outside the radical, those are the same, but that's not what matters. We're looking at the number underneath the radical. Right now, they are not the same, so you might think that you won't be able to subtract these two terms. However, the first step up here says always simplify the radicals first. So this first term, radical 20, can be broken up into radical 4 and radical 5, like we learned last week. Keep the negative 2 in front. The square root of 4 is 2, and you cannot do anything with the radical 5. So this first term ends up simplifying to negative 4 radical 5. And now you actually will be able to subtract 2 radical 5. So these are your like terms now after I simplified. And then you can go ahead and take care of the outside. So negative 4 minus 2 gives you negative 6 radical 5s. You can definitely put this into your calculator. Maybe you might want to use parentheses around this term and then subtract this entire term. And then whatever number you get for this, it should be equivalent to this when you simplify it. So you can always use your calculator to check your work if you want to. All right, so that is a moderate type of problem. I did have to simplify one of the terms in order to combine them, but let's go back to an easier type of problem. So number 1 in your notes. Hopefully you have them printed out so you're following along. Okay, number 1, these are like terms. They both have radical 6 in them. You cannot simplify the square root of 6 anymore. No perfect square goes into that. So let's just simplify. 3 minus 2 gives you 1 radical 6. You don't have to write the 1 in front. You can just simplify it to square root of 6. But then something like number 3, the square root of 7 cannot be simplified, but the square root of 63 can be simplified. 9 goes into 63 7 times. 9 is a perfect square. So this second term, this is actually 2 times the square root of 9, which is 3. So 2 radical 63 is simplified to 6 radical 7. So now you have 10 radical 7 plus 6 radical 7. They are like terms. You can add them to get 16 radical 7 as your final answer. So again, I didn't have to do anything with the first term. The second term, 2 radical 63, right here, is equivalent to 6 radical 7 once you go through the process of simplifying that. And then you get like terms. Okay, let's look at number 5. So with number 5, both of these terms actually will have to get simplified. So what perfect square goes into 32? 16 goes in twice. Notice I still have the 2 in front. Okay, then the next term I still have the 3 in front. 9 goes in. 9 is a perfect square. 9 goes in twice. So when I simplify the first one, simplify the second one, I end up with 8 radical 2 minus 9 radical 2. So simplifying them both, I end up with like terms that I can subtract, and I end up with -1 radical 2. So this is what you're going to do for the first 2 pages. You're using your knowledge from last week. You're simplifying the radicals so that you can add and subtract. On the second page, you may have 3 different terms. So you see that you have this term with a radical 10 and this term with a radical 10. But then this term is radical 6. So you can take care of combining -2 minus 2 to get -4 radical 10, leaving the subtracting 3 radical 6. Can any perfect square reduce 10 or 6? No, so this would just be your answer. So sometimes you might not be able to combine everything. You would just leave it like that. Whereas number 11, let's see if I can combine any. So right now, none of these radicals are the same, so you can't combine anything. But I know that 50 can be broken up into 25 and 2. 18 can be broken up into 9 and 2. And you can't do anything with the radical 3. Okay, so when I do that, I end up with 2 terms that are the same. So I can do -15 plus 3 to get -12 radical 2. And you have to just tack on that -3 radical 3. So you end up with a binomial, which is totally fine. But that's all I can do with simplifying that one. Okay, so maybe take a break, work on these first 2 pages. Don't worry about the applications too much. I'm not too worried about that. And then we're going to move on to multiplying radicals. Multiplying is easier than adding or subtracting. Remember the product rule? So what this basically says is whatever's underneath the radical, you can go ahead and multiply it, and then you simplify it. So looking at number 1, you have 8 underneath the radical, 2 underneath the radical, and then -3 is outside. Never combine outsides with insides. Leave the outsides alone. So technically, on the outside of this first one is a 1. So 1 times -3 gives me -3. 8 times 2 gives me 16. Again, outsides with outsides, insides with insides. Never mix them up. So I have -3 on the outside. The square root of 16 is 4. This one works out as a nice whole number. And then something like number 3, where you can see the outsides with the outsides. you can only multiply 5 with -7, so you get -35, and multiply 10 with 12 to get 120 underneath the radical. So what you're actually going to do now, I did my multiplication, but now I want to make sure I simplify it. So we still have -35 on the outside. I know that 4 can go into 120 30 times. So now you actually have the square root of 4, which is 2. 2 is now on the outside and can be multiplied with -35. So I get -70 radical 30. Can 30 be simplified anymore? It cannot. So this is your answer. So what I'm doing, I'm multiplying and then simplifying. When it involves variables, like with number 5, so again, outsides together, 4 times 1, insides together. 6 times 6 is 36. N squared times n, you have 2 combined with 1 gives you n cubed. So you kind of have to remember some stuff from last week. So the square root of 36 is 6. So if you want to separate the coefficient from the variable, that might help to see that it ends up being times 6. But now the square root of n to the third. Remember, when you're dealing with square roots, you can only deal with even exponents. So I'm going to break it up with n squared and n, because the square root will cancel out with the square. So you're actually going to have 24 as a whole number. You're going to have one n outside the radical and one n left over inside. So that was kind of a lot, but it's just one extra step from last week, is that multiplication. I'll do one more with you, number 7. So outsides, insides, and then I have to simplify. I always like to separate the coefficients from the variables. And I know I want an even exponent. So 6w's will divide by 2 perfectly, and then you're going to have 1 left over to get you that 7. Okay, so 45 can be broken up into 9 and 5. The square root of w to the 6th will be w to the 3rd, and with 1 w left over. So this whole thing, you have 2 times 3, which is 6w cubed, with a 5 and a w inside the radical. That's the hardest that it will get. And then just remember, PEMDAS, do the multiplication before the subtraction, because now at this point we know how to do both operations. So let's do the multiplication, the outsides and then the insides. So right now I can't subtract them, they're not like terms, but I can break up the 20 into 4 and 5. Okay, so I multiplied, I simplified, and now I can subtract to get 54 radical 5 as my final answer. So you have another page to practice with multiplying, I think. Yeah, so you can go ahead and do some of the evens. This page is about distributing, so remember your umbrellas. The only additional thing you have to remember is that the outsides cannot be multiplied with the insides, but the insides can be multiplied with the insides. So there you go, and then you just simplify from here. Okay, so 48 can be broken up into 16 and 3. But after I simplified, you see they're not like terms, so you wouldn't do anything with that. And then over here, you're going to FOIL. So outsides, that's fine. And outside with an inside, okay. All right, so take a second to see where I got this from. First, outer, inner, last, you know how to do, but just keep what's underneath the radicals together and what's outside together. So here we actually have like terms, which is nice. The square root of 9 is 3, so you end up with this as an expression. So same goes, I'll do kind of a harder one, number 13. So I'm going to distribute outsides, insides. Nine and 2 can go into 18. Square root of 9 is 3. And then since no perfect square goes into 30, you would just leave it as this. Okay, so make sure as you're practicing, you're just checking the solutions on Classroom. One more thing, and then we're done, is dividing. So take your time when you're working through the notes. You're going to first break apart the radicals using the quotient rule. That means this. Look for perfect squares, simplify, see if you can reduce anything, and then at the end, make sure your radicals are all the way simplified. So we're just going to deal with some easier examples in this video. You never want to end up with a square root in the denominator, but I think I kept it simple where you're not going to end up having that anyway. So with number 1, what this means is this, and you know both of these are perfect squares, so it works out nicely. And you can't reduce that fraction anymore. But then with something like number 5, so with number 5, since they're both underneath a radical, let's simplify those numbers first. So 5 goes into both, 5 goes into 10 twice, 5 goes into 45 9 times. Okay, so now we can actually take the square root of 9, which is 3. You can't do anything with the square root of 2, but that's okay. It's in the numerator. You can leave it there. And then number 7, those are both underneath the radicals as well. So let's see if we can simplify that fraction. 96 divided by 3 gives you 32. So it just equals the square root of 32. And then you can see what perfect square goes into this. 16 goes in twice. So this actually, the whole thing simplifies to 4 radical 2. And then number 9, 3 in front, don't touch that. But the 5 and the 45 are both underneath a radical. So you can simplify those. So 5 goes into 45, so that would actually be 1 over 9. So you still have a 9 underneath the radical in the denominator. And again, the square root of 9 works out nicely to get 3. And this whole thing actually simplifies to 1. Okay, and then one more to show you the difference. So outsides can be simplified together, and the insides can be simplified together. So you could end up with a nice even 20. Okay, so that's kind of a lot, but you can go back and watch this, pause it where you need to so you can work on the notes. The first 2 pages were adding and subtracting. You can only add or subtract like terms, and then make sure you simplify before you come to the conclusion if you can add or subtract them. Then we covered multiplying. multiply just as you would, just keep the outsides together and the insides together. Once you do that, go ahead and simplify it more. We covered some distributing, some foiling, and then some basic dividing. So those are all of your operations with radicals. Take your time with this week's notes because you don't have any assessment again. Make sure you're checking your answers on Classroom. Next week we have one more week with radicals. Your Albert will be next week. And then we just have to focus on some cumulative review, and we'll meet as a class once your videos turn on. But let me know if you need any help before then, and then we can email or I'll set up a Zoom with you.